How humans learn versus how machines learn. Hello everyone. In this video, we're going to have a brainstorming session around some fundamental questions. How does the human brain learn? And how can we replicate human-like learning in machines? Although how the human brain performs learning remains an unsolved mystery, we have various approaches that enable machines to learn. Supervised learning, unsupervised learning, and reinforcement learning are advanced machine learning techniques used today. Supervised learning involves labeling data with relevant outputs and training the machine to establish connections between inputs and these outputs. In the large language models we use today, self-supervised learning allows the model to generate its own outputs from data and learn through this process. In unsupervised learning, data is grouped based on its features without any labels. Reinforcement learning is an approach where an agent takes actions in its environment, receives rewards or penalties, and learns to maximize those rewards. Humans can learn by observing outputs in their environment. For example, when we order furniture that needs assembly, we look at the assembly instructions to learn how to put the table together. Using our intuition, we could say we're performing a type of learning from labeled data. But here's the interesting part. Even without looking at the assembly instructions, we can form an idea of how the table should be assembled. This means human learning doesn't rely solely on labels. We can also reach conclusions through our own evaluation. By our own evaluation, I mean drawing on past knowledge, such as visually knowing what a table looks like and predicting which parts go where. We haven't been able to give machines such an intuitive approach yet, and AI researchers are still working on how to achieve this. With the neural networks we currently use, we can teach a network what a table looks like and then distinguish whether a table is present in a given image. To do this, we train the system by showing it many images containing tables. Or we can teach language models the structure of human language by providing them with large textual datasets. And with the acceleration of work in this field, significant achievements are being made. However, humans don't learn with this much data. A newborn baby can gradually identify objects in their environment and make accurate inferences. These learning steps seem to be built on a solid foundation that humans have from birth. Among the machine learning approaches I've mentioned, reinforcement learning seems closest to the human learning process. Before I explain why, I want to emphasize that this conclusion is currently a subject of debate. Some researchers believe we perform multimodal learning, integrating multiple types of information simultaneously. Now, let me return to my own reasoning. We appear to perform the labeling stage of environmental data ourselves through a cognitive function. This cognitive function can also automatically evaluate the results of our actions based on what we gain from interacting with our environment. And this function completes the learning process by evaluating it itself. I believe this cognitive function is constantly changing. When we gain more knowledge or work with the limited data we have, the capacity of this function increases. Conversely, we see it decrease with aging, health problems, or reduced use of this function. Developing this function seems to be a requirement for achieving human-level AI.